Hello passengers, this is Captain Lambert on the flight deck. Welcome to the audio universe tour of the solar system. Before we get started, please listen carefully to our pre-flight information. Newcastle University, the Science and Technology Facilities Council, and the Royal Astronomical Society welcome you on board. Our spacecraft is equipped with an amazing sonification machine. This device turns light into sound. For most of our tour, we will use different musical instruments to represent the light from different objects in space. You will be informed when a sound is coming. Remember, sound cannot travel through the vacuum of space. Instead, our marvellous device converts the light it detects into sound. Throughout our journey, please follow all safety instructions from the crew. For now, sit back, relax, and enjoy your flight. Before takeoff, we must test our sonification machine. For our first test, red and blue lights will flash outside the spacecraft. The red lights will be converted into low notes and the blue lights into high notes. Let's begin. That was 2 red front left, 2 blue front right, 2 red back right, 2 blue back left. First test complete. For our second test, we will listen to the light reflecting from a mirror that will circle the spacecraft. I will retune our sonification machine to turn this light into the sound of string instruments. OK, test ready. Let's begin, starting at the front. There it goes to the left. At the back now. Around to our right. Back to the front for one more circle. We're ready to go. Now, a place like this is not good for enjoying the wonders of the universe. If I open the flight deck window, you'll hear how busy it is in the city behind us. There are too many people around here who are producing too much light and background noise. This makes it difficult to study space. Our first stop will be where some astronomers have built telescopes, far from the light pollution of cities and towns. So sit tight, we're taking off. We are now flying over the Atacama Desert in Chile, high up in the mountains and well away from towns and cities. It is so dry that hardly any animals or plants can survive. This is one of the best locations in the world to enjoy the night sky and a perfect place for astronomers' telescopes. Prepare for landing. We are now at the European Southern Observatory's Very Large Telescope, or VLT. I am hovering the spacecraft so that we can get a good view. There are actually 4 big telescopes here, each sitting inside a building that looks like a giant drinks can. These buildings are as tall as skyscrapers. At night, they open up, allowing the astronomers to investigate space. There are no towns or cities nearby. Let's open the windows. Just the quiet breeze of the desert. Now, I will land the spacecraft because we have someone very special joining us to help out on the rest of our tour. I will open the flight deck door and let him in.
Hello passengers. I'm Dr. Nick Bond and I'm a blind astronomer. I've been partially sighted since birth, but this doesn't stop me from using telescopes to study distant galaxies. I don't have to rely on my sight to study space. I can use my other senses as well. First of all, I want to talk to you about the sun. Remember, it's very dangerous for any of us to look directly at the sun.
That's right, Nick. I'm tuning our Sonification machine into the sun's light. Okay, the sun's light will now sound like a steady, low drone. Let's take a listen.
Thanks, Captain. We are facing south, and it is late morning. The sun is up in the sky, slightly to your left towards the east. In a moment, we will speed up time to experience what happens during the day. The sun will seem to move in a westerly direction and then start to get lower until sunset. This is because our planet Earth is constantly spinning, and as we get towards night time, we here on the ground are turning away from the sun.
Okay, speeding up time until sunset. The sun moves across the sky. Now it is over our heads. Working its way towards the west. Getting lower and lower. And now it is gone. The sun has set.
Now is the time of day astronomers call twilight. Although the sphere or ball of the sun is hidden from view, some of its light is still in the sky. The stars are always above us, but even a little bit of sunlight hides them from us. We are going to move further into nighttime until the sun's light has completely gone and the stars will be revealed.
Okay, Nick. I'm also going to retune for the light of the stars.
The stars are like thousands of pinpricks of light spread across the blackness of the night sky. Our sonification machine will first detect the very bright stars emerging, followed by the thousands of fainter stars that become noticeable later. The brighter stars will be louder, and the fainter stars will be quieter. The bluer stars, which are actually hotter, will sound as high notes, and the cooler red stars as low notes. Here we go.
Wow, the stars are so beautiful flickering above our heads. All night long, stars decorate the sky.
I agree, Captain. It's amazing to think that the stars are actually just other suns, so far away that we cannot feel their heat.
Now it is time to leave the Earth. We will take off and study our planet from above. Hold tight. Here we go. Here we are above the Earth, a giant sphere, covered by oceans, lands, towns and cities. Home for all the people and animals we know and love. The reason everything stays on the Earth's surface is because of an invisible force called gravity. Later, we will encounter gravity in action again, in our tour of the solar system. Nick, could you explain to us why one half of the Earth is lit up and the other is dark?
Absolutely. You will hear the sun is off to our left. The sun is millions of kilometres away, but so bright and hot that we can feel its heat. The half of the Earth pointing towards the sun is lit up and feeling the daytime heat. From our position, this is to the left side. The half of the Earth turned away from the sun, currently the right side, is in darkness and is feeling the coolness of the nighttime. The parts of the Earth that are lit up keep changing because the ball of the Earth spins constantly, one full spin each day. Captain, please could you tune into the Earth as well as the sun?
Okay. Let me know when you're ready.
Thank you. We are going to hear the sunlight bouncing off the spinning Earth. The oceans are full of reflective water, acting like giant mirrors. As they pass into the sunlight, you will hear a brighter sound. As the land of the continents, such as Africa and the Americas, moves into the sunlight, you will hear a duller sound. We will also speed up time for 2 full spins of the Earth. That is 2 complete days or 48 hours. We will start with the sun shining over the Pacific Ocean. Okay, Captain, we're ready. Australia and Asia are moving into the sunlight. Now Africa, Atlantic Ocean, Americas, and back to the Pacific for the second spin of the Earth.
Okay, passengers, time to move to a new location so we can study our moon. The Earth is currently in front of us with the moon beyond. The sun is still off to our left. Nick, can you tell us about the moon?
I can. The moon is a sphere of dry, dusty rock about 5 times smaller than our Earth. The moon is only visible to us because sunlight bounces off it. Let's select a piccolo to convert this light into sound.
No problem, I'll retune. Okay, let's take a quick listen.
Due to the force of gravity, the Moon does not float off into space, instead travelling around and around the Earth. One complete circle, called an orbit around the Earth, takes about 27 days, roughly 1 month. Captain, let's listen to the light from both the Earth and the Moon and speed up time for 2 months.
OK, Nick. We'll use a clarinet sound for the Earth and keep the piccolo sound for the Moon. We will stay facing the Earth and hear the Moon travel behind us as it orbits around the Earth. The Moon is to our left, behind us, to our right, and now one more orbit. Time to move on. We have just enough fuel to visit the Sun and learn about the 8 planets of our solar system. It's a very long way to the Sun, 150 million kilometres. If we travelled at the speed of a jumbo jet, it would take about 20 years to reach the Sun. However, we're going to speed up time and arrive there in moments. Here we go.
We've arrived. The Sun is so big. It would actually take 1 million of our Earths to fill it. However, the Sun is not empty. It is a giant ball of gases. Mostly a gas called hydrogen, which is extremely hot. Thousands of degrees on the surface and millions of degrees in the middle. Captain, please tune our sonification machine back into the Sun.
Just to prepare you passengers, this one is going to be loud and powerful. Let's turn the volume down a bit so we can hear Nick tell us a little bit more about the Sun.
Just like the Earth and the Moon, the Sun is a sphere. However, the reason the Sun is so hot is because, like all stars, it is a giant nuclear fusion reactor, where gas particles come together, releasing extraordinary amounts of energy as light and heat. This energy is what makes the Sun a star. Planets and moons do not produce their own light. Let's turn up the volume again so we can appreciate the power of the Sun. The Sun is so powerful that it provides us with the heat and light we need to live on the Earth, even though it's millions of kilometres away. Of course, the Earth is not the only planet in our solar system.
Let's turn around so that we can study the other planets. Nick? I've kept us quietly tuned into the Sun, and now I'll tune in ready for all 8 planets.
Thank you, Captain. The planets are millions and millions of kilometres away from here. From this distance, they just seem to be tiny dots of light. However, our sonification machine can detect the light, and we can use our onboard camera hyperzoom for a closer look. Okay, we have tuned to a flute sound for Mercury, the closest planet to our Sun and the first of the 4 rocky planets. Mercury is the smallest planet in the solar system, and a bit like our Moon. The surface is covered in craters where large space rocks have collided with the planet.
The second planet from the Sun is Venus. We will use an oboe sound.
Venus is slightly bigger than Mercury, but is very different because it's surrounded by an atmosphere of thick clouds. The atmosphere would be very poisonous to humans and traps the sun's heat through the greenhouse effect. This makes Venus the hottest planet in the solar system. At over 400 degrees Celsius, it is twice as hot as a kitchen oven.
Earth is next. Once again, we will use a clarinet sound for our home planet.
Earth is a similar size to Venus, so we can choose a similar note. Earth is the only place we know where life can survive. The temperature is just right, so lots of liquid water can exist, a vital ingredient to support life as we know it. Maintaining these conditions is a very delicate balance. Even slight changes in temperature could make it difficult for life to survive. We must take care of the Earth.
Moving on to the 4th planet from the Sun, and the last of the rocky planets, Mars, for which we will use a saxophone sound.
Mars is about half the size of Earth, so we used a higher note. Mars is nicknamed the Red Planet because of its dusty red surface. It is the only other planet that humans will visit anytime soon. Right at this moment, robotic rovers are exploring its surface for signs of current or extinct life. This is a very exciting time for space exploration.
Now we move on to the gas giants. The first of these is Jupiter. We will use a powerful trombone sound.
Jupiter is by far the biggest planet in our solar system. Like all the 4 giant planets, it is a huge ball of gas, but is still a planet because it is not producing its own light like the Sun does. Jupiter is so large that many flying space rocks are pulled onto it by gravity. These rocks might otherwise collide with Earth. Jupiter helps to protect us.
The 5th planet from the Sun is Saturn. Let's use a euphonium sound.
Saturn is famous because of the bright rings of small rocks and ice surrounding the large central ball of gas. Like all gas giants, many moons orbit Saturn, some small and some big. Not just one single moon like our Earth has.
And for the 7th planet, Uranus, we will use a trumpet sound.
Uranus is famous for spinning on its side. Astronomers think it might have been knocked over billions of years ago due to a collision with a space rock twice the size of the Earth.
And finally, the 8th planet of our solar system is Neptune, for which we'll use a French horn sound.
Neptune is so far away from the Sun it is very cold. 200 degrees Celsius below zero.
So there we have it. The 4 rocky planets and the 4 gas giant planets. We do not have time to visit them today, but the solar system also contains many more objects such as asteroids and comets. We are going to travel to a position between Mars and Jupiter, where we will enjoy all of the planets together. Hold on tight. Now we are turned towards the Sun. We will show you how the planets orbit around the Sun. Nick, can you tell us more?
Yes, Captain. Planet Earth does one full orbit of the Sun in a single year. That's 365 days. The planets closer to the Sun go around much faster, and the planets further away go much slower. Mercury only takes 88 Earth days for one orbit, but Neptune takes 165 Earth years.
We will speed up time considerably so that we can listen to all of the planets go round the Sun. After the Sun, we will add one planet at a time until we can hear all of the planets together. Starting with the Sun. Adding Mercury, one orbit in just 88 Earth days. Next, boiling hot Venus. Our home, the Earth, 365 days for one orbit. Mars, the red planet. Giant Jupiter. Next, ringed Saturn. Adding the side-spinning Uranus. And finally, freezing cold Neptune. Fading out now. Wow, our solar system is an amazing place. But is it the only solar system, Nick?
No. We will now start flying using super sped up time away from the Sun and pass by other stars. Our Sun is just one of billions of stars in what we call the Milky Way galaxy, which is just one of billions of other galaxies. Astronomers have already discovered other stars have their own planets orbiting them. Just think, there must be billions of planets out there. Perhaps there are even others just like our Earth.
That's amazing, Nick. Let's tune our Sonification machine back into the stars and appreciate just how many stars there are all around us. Nick, our fuel gauges are telling me it's time to head home.
Okay, Captain.
Let's go. Hey Nick, we're passing the Hubble Space Telescope. It's floating in space.
Yes, we've talked about telescopes in the desert, but we can also put telescopes in space. This telescope has been observing some of the most distant parts of the universe, and helping us understand how galaxies like our Milky Way were created.
OK, everyone prepare to re-enter the Earth's atmosphere. We are about to land. And we're home. On behalf of myself and Nick, I would like to thank you all for joining us on our audio universe tour of the solar system. Remember, we heard about many amazing planets, but our precious Earth is the only one we can live on. We must all take great care of it.
And thank you, Captain Lambert. We hope that you have all had an enjoyable journey where we did not have to rely on sight to explore space. Anybody can be a scientist if they want to be. Goodbye, everybody.
Goodbye.
The Audio Universe Tour of the Solar System was brought to you by Rachel Lambert as the captain, Nick Bond as himself, Chris Harrison as director, Theophanis Matsopoulos for planetarium production and 3D visualization, James Trayford as principal sound designer, Lee Harrison as musical director and composer, Amrit Singh as chief advisor, Steve Toes as script editor. We are also grateful for the valuable contributions from the Institute of Cosmology and Gravitation at the University of Portsmouth, Ashwarya Girdhar, Anita Zanella, Jeff Cookie, Fia Damshmar, Gary Foran, Ruben Garcia Benito, Miranda Jarvis, Liz Milburn, Enrique Perez Montero, Stefania Verano, Newcastle Children's Vision Team, the Views Group Newcastle, and the Great North Museum, Hancock.